Welcome again, ladies and gents, to another flipped lesson. Today our focus is gas stoich. That's right, Stoich magic is back and bigger than ever, guys. We're going to add one little thing to our mole map. I promise you it's not too terrible. And what we'll focus on today in this video is just what that conversion factor is and how you can use it. Tomorrow we'll talk more about the mole map itself. So for this set of notes, you guys need to have your packet out, something to write with, and a calculator. Let's get started. Now the new conversion factor we're adding to our mole map is called molar volume. So what the heck does that mean? When we talk about molar volume, what that means is it's for an ideal gas at STP, and that value is equal to 22.4 liters per mole. So the most important part of this definition, aside from the conversion factor being 22.4 liters per mole, are these three little letters here, STP. These are the guys that set the parameters for molar volume. So we can only work with this conversion factor if we see the letters STP in the problem. So what does STP stand for? What it stands for are a set of conditions known as standard temperature and pressure. So if you're at standard temperature, what that means is you're doing your experiment at 0 degrees Celsius, which we know is equal to 273 Kelvin. And the pressure in your room is either at 1 atmosphere, 101.3 kilopascals, or 760 millimeters mercury, depending on what pressure unit you're using to measure your pressure. So these are the conditions that you must have for STP. You must have 0 degrees Celsius, you must have 1 atmosphere. If you're hotter than 0 degrees Celsius, or you have a pressure that varies away from 1 atmosphere, you are no longer at STP. So these are the conditions that you must have in order for us to call you STP. So what researchers realized as they were kind of working with different ideal gases in the ideal gas law is anytime they put 1 mole of gas into a container that was at 0 degrees Celsius and 1 atmosphere of pressure, the volume always changed to 22.4 liters. It did not matter what gas was present, because when we look at ideal gas law, all we put into the equation is how many moles we have of that gas. It doesn't matter if that gas is hydrogen or oxygen or water vapor or carbon dioxide. All that matters is that there's 1 mole present. So no matter what gas the scientists were putting into their chambers, every time they put 1 mole at 1 atmosphere and 273 Kelvin, the volume always became 22.4 liters. And because of that, we call this molar volume. So molar volume is going to be 1 mole equals 22.4 liters. But you can only use this conversion factor if you are at STP. So those are the 3 letters we need to see in the problem that tell us, all right, we're at standard temperature, standard pressure, we can use our molar volume. So what would a problem like this look like? Oh, I'm sorry. So how do we use this in the mole map? You'll notice up here we have our mole map from semester 1 that we added to in chapter 9, and we've added 2 boxes down here to this little middle area. These 2 boxes are where we're now going to add the word volume. So this box would be your volume 2, and this box over here would be your volume 1. So how we add into this mole map is we're going to talk about this middle arrow here. This middle arrow, I call this the fast track. You can only use that middle arrow if you're at STP. We'll talk about the outside arrow tomorrow. So the middle arrow is only for use when you're at STP. So if you're at STP, you can use your molar volume where 1 mole equals 22.4 liters as your conversion factor to go from the volume of 1 gas into anything for the second gas. You can go from volume 1 to volume 2, you can go from volume 1 to mass 2, you can go from volume 1 to mole 2, you can go anywhere on this side because we learned how to use this mole map in chapter 9, and we'll review that a little bit tomorrow. But at STP, we can use our molar volume. 1 mole equals 22.4 liters. So what would a very simple problem like this look like? If you flip your note packet over, a very simple problem would read like this. A sample of nitrogen gas has a volume of 1.75 liters at STP. How many moles of N2 are present? When we're tackling this problem, there's two things we want to look for. One, do we see STP? And we absolutely do. So since we see STP, we know that we can use the conversion factor of 1 mole equals 22.4 liters. The second thing we want to ask ourselves is, are we actually going anywhere to the right on our mole map? So if we look at the problem, I've got 1.5 liters of nitrogen gas, and I want to know how many moles of nitrogen gas are present. So since I'm starting with nitrogen gas and I'm ending with nitrogen gas, I'm only staying on the one side of my mole map. I'm going from volume 1 to mole 1. So this is one arrow, so it's a one-step conversion factor. So how we would set this up is we would say how many moles of N2 are equal to 1.75 liters of N2. Because I'm at STP, I can use my molar volume conversion factor. Since I'm starting with liters, that means the 22.4 needs to go on the bottom of my conversion factor to cancel. So my 22.4 liters of N2 is going to be equal to 1 mole of my N2 gas. So I cancel my units, and in my calculator, I'm going to do 1.75 divided by 22.4. And when I punch that in, when I round to proper sig figs, which should be the number 3 sig figs, I would get the answer of 0.0781 moles of N2. And that's it. That's all you'd have to do. Tomorrow, what we're going to focus on is how to do those harder, more complex problems with the mole map, and then we're just going to practice in class. So I'd like you guys to go ahead and head to the website and fill out the Google form that goes along with this video, and we'll talk about molar volume a little bit more tomorrow. Have a great night, guys.